Okay. Hello, everyone. Professor Lee went to a teaching trip to Japan, so I'm the PhD student of his lab. So today I will give you a lecture. Actually, I don't know who's time, and I heard he teaches like until here. Is it like we should start from here? Yes. And how much foreigner students here? Foreigner students. If you cannot understand my English, please let me know. Then I will start from here. Today I'm gonna give a lecture for chemical kinetics, especially for the slow steady state example. What is the slow steady state example? In the chemical reaction, you can see that some immediate chemical compound which are very active. So it can be consumed very fast, and also it also decomposes very fast. So we cannot see in the product. That is the we are saying immediate product. So I will give her some example. You know, this is the hydroperoxide, and this N is some chemicals, and they can make these hydroxide radical ions. But as you know, this chemical is very active to react with other compounds, so it can be consumed very well, and it can also be disappear as another compound. Like this. This is the superoxide compound. So they kind of free radical also included in the kind of immediate product. And here is some example. Just to let's assume this A compound is react with the M, and they can make this A star compound. This is the immediate compound. So this chemical kinetic constant is the K1. And as I already told you, this A star immediate compound can be disappeared very fast. This also can be reacted with this N and also go back to A again. This is the reverse chemical reaction. So this chemical constant is the K minus 1. And this is the second reaction. If there is A star, they can make B and C. This is the product. So total reaction is the A becomes B and C. As you can see, there is no A star in this the LAN reaction, so we can say that A star is the immediate compound. So we are using this kind of the immediate compound further to get the concentration of the final product. That is the pseudo steady state approach we are saying. Just to see this A concentration, dA over dt becomes this is the first reaction. A is the consumed by this M, so this minus means disappear of A. So minus K1 and the A and M. Yeah, this is for this reaction. And you can see here, A is the productive from the reaction. So this plus means the production of chemical. Yeah, so K are -1, A star, and M. So this is the equation for this change of the A concentration. That is the first reaction. And how about for this A star? A star, you can see here, A star is productive. So the K1 AAM means the production of A star from here. And here, the minus means this A star is disappearing in this reaction. So this minus means for that. And finally, also this reaction consumes A star for the reaction. So there is also minus for this one. But this A star, there is some reaction and reverse reaction at the same time. So the concentration is always zero, almost zero in the net system. So we can just approximate the concentration of A is zero. So this is the PSSAT, pseudo steady state. Yes, this kind of assumption we are saying pseudo steady state approximation. So this becomes zero because this is zero. Yeah, and then we can calculate all of the concentration using the two equations I already. So the equation 1 and equation 2. Yeah, okay. Are we? If we are, it's K1 and A star. And plus K2 A star is we can make this kind of equation using the equation 2. And this is we want to know this mole concentration. So if we and just to divide this one as this one. So you can see the A star mole concentration can be expressed by only K1 and A and M. We already know this kind of the concentration. So, and then, just to input this A star to here, A star. Yeah, this can make the. This is the final equation. Okay.
저기 18정식에서요.
예.
저기 K1 A 스타 M 스타고요. 그 우변에는 또 K1 M A 하고 M인데 그 중에 하나는 A K 마이너스가 돼야 하잖아요.
아니, 아까 저 A 스타 있는 K. So you understand what I'm saying? Is there any question? Okay, no question. Actually, this is my first lecture. Certainly, he asked me to have a lecture, so I'm embarrassed. But I will do my best. So yeah, if we input this A star into here, this equation, here A star, and then rearrange this equation, you can get this final equation. The concentration of A can be expressed as the K1 and K2, and the MA and K2. And all of these information are given already, so we can get this change of the A concentration. And then if you think, in the fraction, if this one is highly larger than this K2, this equation, this can be ignored. So only left this one and this one, and you can remove M. So the equation can be like this. And secondly, if K2 is highly larger than K minus 1n, you can ignore this expression, and you can remove K2 and K2. So the equation can be expressed as like this. That is the PSS 80. So this approach is highly used in the chemical reaction, especially for the very fast reaction. You cannot find out in the ozone also there is a free radical production by the UV. So we can just apply this PSAT to get the concentration of the immediate compound. So just to keep in mind, maybe he will, when is your intermediate? 2 weeks or something. 2 years. Maybe he will give this equation. And secondly, this is the Arrhenius equation. Have you heard about this Arrhenius equation? Arrhenius equation is like this. The K, kinetic constant, is the A exponential minus EA over IT. And so in the equation, the activation energy is very important. Activation energy is the EA, and here is the energy after chemical reaction like this. This is the activation energy. EA. We have this is the activation energy. And also the temperature is very important term. So what do you think? If the temperature is closer, the kinetic will increase or decrease? Increase. Especially increase. Commonly increase. There is some reaction with the temperature is closer, the kinetic is decreased. But it's the very special case. Usually the temperature is proportional to the kinetic constant. And this is the Chaman reactions. I think you already studied this equation. the ozone layer part. Yeah. This oxygen can react with this UV and can make the oxygen atoms. And here is also this M and M star. So as you can remember, this M star is the immediate compound. So we can adapt the PSST to this Chapman equation. That is the purpose of this lecture. Anyway, there is also given information for kinetic constant for all of reactions here. Okay, so let's make same the equation using the given information. How about for O3? O3 here. O3 is the made from this O, O2, and so you can see the production of O3 here. And how about here? O3 is consumed, so there is minus term. Also here, O3 is consumed, so here also have a minus term. And how about the oxygen? Only oxygen. Single oxygen can be made from this reaction, so you can see. This 2 means the production of 2 atoms at one time. So you can see here, 2 atoms are produced from this reaction. And this minus means here. This single oxygen can be consumed. So this is the minus, and this is the production of single oxygen. And also here is the consumption. So here is minus. So we can make this kind of equation for this Chapman equation. And then important thing is in a Len reaction there is no this single oxygen, so we can say this is the 0. So here belongs 0 here. And just to assume that this K1O2 is highly smaller than K3O3, you can remove this term, K1O2, here. You can remove this one, and just here, and that means this one. This assumption is the cross, the multiplication is this one. And then just to remove this one, and we can simplify, express this equation as like this. You know what happens? There is no term for this one. Only just cross this term to K3O3 and remove the 2 also. So this means this equation. You can understand. And only left this O and divides this K2O2M here. So we can get this expression for single oxygen. And just to go back here, and just all the equation. Just these 2 equations. Then if some term will be disappear. How about same one? This one minus, and this one is the plus. So if we add these 2 equations, it can be removed. And there is a same term. This is minus, so it can be 2. and 2. Yeah, this one is plus and minus, so it will be removed. So only this term and this term will be there. So you can see. Yeah, this can be 0. Because we assume this one is also 0 and this one is 0. So addition of. And then this equation contains the single oxygen concentration, so just all these term here. Yeah. And then rearrange the term, and you got the final equation term. So O2 squared and O3 squared equals like this. And as you know, we already know this information, K1, K2, K3, K4, and the concentration M also are given. So finally, we can get this O3 the concentration. The O3 is very active compound, so you cannot see in the real reaction. But using the PSSAT, we got the concentration of the O3 in the mass system. So this approach is very useful. As you can see, the concentration is very small. Yeah. So we cannot measure the concentration by using some analytical equipment. It's very hard. But yeah, based on this equation, we can find out some value. Usually, Professor Lee give homework for this one. Then, yeah, just to try. It's not a mandatory, just to try, but for your meeting. Actually, he said just to stop here. Yeah.
네, 질문하는데 그 반응식에서요. 예. 그 앞에 계속 이가 왜 하셨는지 잘 모르겠어요. 이게 단위 단계 반응식으로 이루어진 거면 개수가 지수로 올라가잖아요, 속도식에서. 예. 근데 개수로 내려, 속도식으로 개수가 내려와가지고요.
이 부분 말씀하시고. 저도 이제 이거 강의 준비하면서 고민을 많이 했는데, 이쪽 표현에서 보면은 이제 아까 말씀하신 대로 이제 앞에 개수가 지수로 올라가는 게 맞는데, 그러니까 이쪽 이제 PSSAT 할 때도 원래는 제곱을 제가 일반화 할 때도 제곱을 썼었거든요. 근데 뭐 이렇게 근사를 해도 되는 것 같아요. 이 책 전체 전반적인 흐름을 보니까. 이 책은 이제 하이트라는 교수님이 쓰신 건데, 제가 봤을 때 이제 학계에서는 사람들마다 조금씩 접근 방법이 틀리더라고요. 그래서 여기서는 그냥 두 개가 생성되면은 앞에 2를 나오게 하는, 그러니까 전반적인 이퀘이션에 다 그렇게 표현을 해놔갖고.
근데 제곱으로 할 때는 지금 같은 경우는 만들어지는 거 두 개가 만들어진다고 되는 거잖아요. 제곱을 할 때는 제가 알기로는 똑같은 A랑 반을 해서 뭔가 나올 때가 제곱이 되는 거고, 지금은 생성이 되는 거니까 반이 한 번 가면 두 개씩 생성이 되니까 이게 앞에다 붙여야
그게 가장 논리적으로 타당한 거죠. 그러니까 이 친구가 이제 얘기한 대로, okay, I will just to speak in English. They ask why the yeah. 2 is attached on the equation. So, as you know, some chemical reaction, the production of two chemicals. Yeah. These two means the error one, the chemical reaction, they can produce the two chemical at once. So we should 2 over the ahead of their equation. So if there is a 4, we should attach 4, and there is a 5, we should attach 5. That was my explanation. Okay, there is some time left, so I will go more. Actually, Professor Lee just wants to stop there. Yeah, but if you want to stop, yeah. So then I will stop here. But 20 minutes are left per class, but I will just have 10 minutes more, and you will go back to your home.
Wow.
Yeah. So how about talk about some individual talking? Yeah. Because, yeah, I'm also not just to consult this lecture because it's not my job. But there is camera, so. Okay, so I will limit the camera, so we can limit the file. So, how about his lecture? Usually, you can understand well. And how about the speed of his lecture? Was there adaptable or speed? And you will get the 2 exam, midterm and final. I was the undergraduate student. I had a 4 exam for this class. Yeah. 4 exams and 5 quizzes. Yeah. So there was only 4 students. So he just changed some strategy, just to friendly student. So now I can see there are lots of students here. Yeah. All of you guys are sophomore? No?
No, just in second semester.
Second semester. And you are in the civilian environment. You're making. Wow. I was I was also a student of environmental science, and in my period, there is only 5 students for civilian environment department. So, yeah, so one by one, 3 professor and 1 student can handle, with this professor morning and at lunchtime, dinner time. So I don't need to pay my the proof. And you know there's some scholarship from the department. Yeah. Usually we are giving some scholarship from the first to 5th, but we are only the 5th students are there. So all the students got their scholarship from the department. That is good. Yeah, so who want to be an environmental scientist? You? Yeah. So you like Professor Lee?
Kind of.
Usually very kind to the undergraduate student, but he's very, how can I say, he's a nice man, but sometimes very abstract for the research work. So you can get lots of experience from him. So yeah, just to follow him well. And you have any questions for his class? Some information for the exam problem, and yeah, how can I get the good grade for this one? Just the problem. Actually, I'm the leg captain for this, so sometimes I just pick up the program. Yes, before the exam. I can give you some hint. Yeah. Good information.
그럼 교수님이 내주시는 숙제랑 시험 문제가 그냥 무슨 연관인가요?
거의 비슷해요. 숙제에서 이제 약간 심화된 그런 거 내시고, 교수님이 이제 좋아하시는 게 일상 생활에서 이제 다뤄지는 그런 환경 문제를 시험 문제를 갖고 온 거예요. 그래서 이제 저희 때는 막 그런 거 냈어요. 소주 이제 마이글린에 10ppm의 산소가 녹아 들어가는 게 그게 당 한지에 대해서 실제로 이제 계산을 해서 이제 증명하고 이런 것들. 그리고 이제 교수님 스타일이 뭐 핵심을 딱 잘 짚고 원하는 그런 답. 교수님이 좋아하는 몇 가지 단어들 있잖아요. 페이트, 인바이러먼트, 페이트, 트랜스포테이션 이런 얘기 안 하죠. 이제 주로 자주 쓰는 표현 그런 거를 시험지, 답안지 많이 쓰면은 이 학생이 이제 잘 들었구나 생각하고, 그리고 어차피 근데 채점은 저를 비롯한 이제 다른 학생들이 많이 하기 때문에 친해져요. Your grades is up to me. Just get friendly with it. So, maybe I saw you in the FDC class. You made this. Yeah, yes. What was that? FDC, freshman. Freshman. Yeah. You were, the design was interesting. Oh, that you remember.
Great.
Wow.
Only the guys at the age was. Not only, but very few students that got the A+. But yeah, it is. I cannot remember. Where are you from?
Ukraine.
Ukraine. Maybe you're from India. Not?
프랑스.
France?
네.
우리 그쪽에. Azerbaijan is near Ukraine. So international class. You guys are exchange student or just exchange? From which university? UGT.
University of Technology.
I don't know. We are the ones. And I remember.
Yeah.
He was my student for the FDC. So you got the good grade? So.
I just missed.
And my
I think it's quite good. Compare with time they spend we spend on this.
Okay. If you have a question, I will answer, and if you don't have any question, I will let you go.
I have questions. Why students in environmental science must study so many subjects relating deeply to structural mechanics, materials, or some subject like that?
Subject, professionally subject.
No, I mean, why student in environmental engineering must study so many subjects relating to construction, like mechanics, materials, or some mechanics.
in this department.
Yes.
Yeah, actually, yeah, you are right. We are in the environmental, but it's a civilian environment. The civil is the most major part for this department, so it's a common course. And as you can see, for the environmental science, there is only 5 professors are here, and more than 10 professors are for the civil and structure and soil mechanics. So, but sometimes you can adapt that kind of mechanics on the environmental problem, and we should also learn for the mechanics because it's the basic for this science and technology. Yeah, so just to think positively, your knowledge will be applied anywhere. Yeah, but you are right. There is the very large portion of the mechanics for this department. So in my case, I just interacted the environmental course from Professor Shin and Professor Lee. Yeah. So in one semester, I took the 2 environmental course and 1 civil course. So yeah. So you can arrange your time schedule. You want to be an environmental scientist? But you are just curious.
Yeah.
You're a nice guy. And is there any question? 예.
내일 조선 아니.
아, 네. 저 좀 부끄러워갖고. She asked my email address. So just to understand, you will be left. My genius, yes. Yes. And my office number is 3213. So you can drop by me anytime.
This building or W16 building?
Yeah, same building. Here.
시험 물론 한국어 써도 되겠죠?
시험 문제는 근데 영어로 낼 건데.
풀이요.
풀이는 한국어. 우리도 그걸 원해.
One more question. Why people place environmental science next to civil engineering instead of placing it next to some other fields like the science or mechanical engineering? So it's maybe some close ties between two.
You mean why the environmental department is smaller?
I mean why people usually place 2 fields, environmentals and civil.
Here.
And
That separation.
instead of placing environmentals here, mechanical or the science.
Actually, the environment and civil are related very well. The environmental science was from the civilian environment, especially for the water and wastewater treatment. When you build the water and wastewater treatment plant, it's a civil part, but we should consider the environmental factor. Also, the dam, dam, yeah, it also relates to the environmental science, but so these departments are combined, but nowadays the famous university are separating because the civil part cannot include the environmental issue like global warming and some marine contamination like that. So yeah, now the trend is the separating of the civil and environment. But the basic fundamental is from the civil. Yeah, that is the one. Okay, so you don't have any question, you can go. And just if he asked you how was the class when I was not here, so just to say it was amazing.